All right, 2.4, we're going to talk about complex numbers. So complex numbers are square roots and imaginary numbers. So we've kind of talked about square roots before. We're going to really focus on imaginary numbers for this section. So the imaginary unit comes from the square root of -1. So we've talked about it before where we can't take the square root of a negative because it would give us an imaginary number. So the imaginary unit is the square root of -1. If I squared both sides, so let's say I had I equals square root of -1, and I squared both sides, square root and squared would cancel out. So I squared equals -1. So these are two important things to know. If you have a negative under the square root, you always take it out, turn it into an I. And then I squared, we can simplify. It becomes a real number when you change it to -1. Next page just shows us if we have -5 plus the square root of -9, it would be -5 plus 3i. So we evaluated the square root of 9, which got us 3, and then the negative turns into an I. We always want to write our imaginary numbers in standard form. So that is a plus bi, where the real part comes first. So always the real part comes first, the imaginary part comes second. Next page talks about the same thing, the definition of a complex number. So again, you always want to write it in standard form, where the real part comes first, the imaginary part comes second. So the part that has an I, we write second. And then on the next page, we have the equality of complex numbers. If we said that a plus bi equals c plus di, then the real parts are going to be equal to each other. So it says a equals c, and the imaginary parts would be equal to each other. So b equals d. Next, we're going to be doing operations with complex numbers. So we're going to be adding, subtracting, multiplying, and dividing. When adding, it's kind of like with variables. You can add your like terms together. So real parts can get added to each other and imaginary parts can get added to each other. You can't add an imaginary part to a real part. You just have to leave them separate. Same thing with subtracting. So looking at example 1, when we're adding, you can just get rid of the parentheses, add your real parts together, add your imaginary parts together. So 3 plus 2 would be what? 5. And -I plus 3i would be 2i. And then always make sure you leave it in standard form. I have my real part first, my imaginary part second. For b, same thing. We're adding, so I can just get rid of the parentheses. I want my real part to come first, so that would be -4. And then I have 2i minus 2i, which would be what? 0. They just cancel. So our answer would just be -4. What do you think I have to do first for C? Awesome. Whenever you're subtracting, you want to distribute the negative first. So again, it's super similar to just when you have variables. You kind of treat it the same. Your variable is just going to be an I. So here we have +2. So it'd be 3 plus 2 minus 3i minus 5 plus I. So I'm going to combine my real parts together and then my imaginary parts together. 3 plus 2 minus 5 would be what? 0. 3 plus 2 is 5. 5 minus 5 would be 0. So they cancel. So I have no real part. My imaginary part would be -3i plus I, which is -2i. So that'd be our answer. What do we do first for D? Distribute the negative. So this would become -7 minus I. Now let's combine our like terms. So the real parts first. 3 plus 4 minus 7 cancels. And then 2i minus I would be what? It cancels out also, so what's our answer? 0. We can also multiply with our complex numbers. similar to multiplying with variables, one thing that you need to keep in mind, especially when multiplying, if you have an I squared, you always want to change that to be -1. So you'd never leave your answer with I to an exponent. You could have I, just I, but if you have I squared, you want to change it. If you have I cubed, you want to change it. So always simplify your I. So in A, I'm going to distribute to 4. So this gives us -8 plus 12i. Is this in standard form? Yep, so we're good. Let's do B. So I times -3i would be what? -3i squared, and I squared changes to -1. So -3 times -1 is +3. Awesome. Good job. What do we have to do for C? FOIL. So 2 times 4 would be 8. 2 times 3i is 6i. -I times 4 is -4i. And then -I times 3i would be -3i squared. We want to combine our like terms. And I'm going to change the I squared to be -1. Well, what's -3 times -1? +3. So 8 plus 3 would be 11. So I start with my real part, which is 11. And then my imaginary part, 6i minus 4i would be 2i. Awesome. Now let's look at D. What can we do for D? We could FOIL, but looking at D, what are they? They're conjugates of each other, so we could do our conjugate shortcut. Our conjugate shortcut is a squared minus b squared. So our a would be 3 squared minus 2i squared. So we get 9 minus 4i squared. And what does I squared change to? -1, so it makes it a +4. And 9 plus 4 would be 13. And then lastly for E, write it twice and FOIL it out. So 3 times 3 would be 9. 3 times 2i would be 6i plus 6i plus 4i squared. What would we do next? Change the I squared so it makes it a -4, and then we can combine our like terms. So 9 minus 4 would be 5, and 6i plus 6i plus 12i. Is this in standard form? Yes. Make sure you leave your answer in standard form. All right, so in the last couple sections, we talked about conjugates and our conjugate shortcut. If I had something like, let me change the color, x plus 3 times x minus 3, our conjugate shortcut to FOIL this out was a squared minus b squared. So this would be x squared minus 3 squared, which would be 9. Now the conjugate shortcut, when you have an imaginary number, so when you have complex conjugates, it's a little bit different just because when you have an I, that I squared changes the sign. So instead it becomes a squared plus b squared. So just be careful with this. You can do it either way. Do your a squared minus b squared, but then you just have to change the I squared. So the complex conjugate shortcut, if I had something like, let's say x plus 3i times x minus 3i. If we did just our regular conjugate shortcut, that a squared minus b squared, we'd have x squared minus 3i squared. So x squared minus 9i squared. And what does I squared change to? -1. So -1 times -9 would be +9. So it's kind of skipping that extra step of changing the I squared to negative. It just says square the first one and then square the number in front of your I. So it'd be x squared plus 9 squared, or plus 3 squared, which would be 9. So you can think about it either way, just be careful. I like to write it out so I see the I squared changing. Just be super careful with your signs. So in example 3, it says multiply each complex number by its complex conjugate. So 1 plus I, what would the conjugate of this be? 1 minus I. So we can do our conjugate shortcut. So that would be a squared. I'm just going to do the regular shortcut, a squared minus b squared. So we get 1 squared minus I squared. It's going to be an extra step than the complex conjugate shortcut, but I like to see it this way. So 1 squared would be 1. What's I squared? So minus negative 1, which turns into plus 1. So 1 plus 1 would be 2. And then let's do B. What's the conjugate of 4 minus 3i? 4 plus 3i. So I'm going to do my conjugate shortcut of a squared minus b squared. So we get 4 squared minus 3i squared. So 4 squared would be 16 minus 9i squared. And what does I squared change to? Negative 1, so it makes it a plus 9. So 16 plus 9, 25. So again, the way I'm doing it is an extra step because I'm leaving the I in it and then simplifying. If you want to just do 4 squared plus 3 squared, that works too. But just make sure you know the difference. You can do your complex shortcut when you have I's. You would leave it as a plus, or it ends up changing into a plus. When there's no I's, it should be a minus. Next, we're going to be dividing complex numbers. Our goal is to always get I out of the denominator. So to do that, we multiply by the complex conjugate of the denominator. So in example 4, I'm going to write the complex number in standard form. So our goal is to multiply, or our goal is to get the I out of the denominator. So we want to multiply by the conjugate of the denominator. What's the conjugate of 4 minus 2i? 4 plus 2i. And what we multiply to the bottom, we also have to multiply to the top. So in our denominator, we can do our shortcut because they're conjugates of each other. So a squared minus b squared. So that would be 4 squared minus 2i squared. 4 squared would be 16 minus 4i squared, and I squared changes to plus. So 16 plus 4 is 20. So in our answer, our denominator is going to be 20. So we got I from out of the denominator. What do we have to do on top? Foil. We're going to foil the top. So 2 times 4i, I'm going to do the work down here so we have space. 2 times 4 would be 8. 2 times 2i is 4i. 3i times 4 is 12i. And 3i times 2i is 6i squared. What would we do next? Awesome. I squared changes to negative 1. And negative 1 times 6 would be negative 6. I'm going to change the sign. Then we can combine like terms. 8 minus 6 would be 2. And 4i plus 12i is 16i. So we've got 2 plus 16i. Can I simplify this? Are all 3 of my whole numbers divisible by the same thing? Yeah, we can divide them all by 2. So let's simplify. Always simplify if you can. So here when we simplify, we get 1 plus 8i over 10. This would be perfectly fine on a test or quiz. I'm not sure if WebAssign's going to take this. Sometimes WebAssign likes it when you split up the answers. So it'd be 1 over 10 plus 8i over 10, which 8i over 10 actually simplifies more. What does 8i over 10 simplify to? 4i over 5. Perfect. So I think WebAssign would probably want it this way. You can try putting it all in one fraction on WebAssign, but if it marks it wrong and you know that you did it right, break it up. So that way you have your real part first and your imaginary part second. We're going to be doing quadratic formula to solve quadratic equations, and it's not always going to work out to be a real number. So when we do end up with a negative under the square root, you always want to take it out and turn it into an I. So this is just like the principal square root is when you take out the I. So this is kind of just vocab. But when we do quadratic equations, don't leave the negative under the square root. And since we're dealing with imaginary numbers, don't tell me no real solution. I want the imaginary solution now. So take the I out of the square root. The notes leave the I behind the square root. You can write it in front. I like to write it in front just so we're not confused if the I is, if it's under the square root or not under the square root. WebAssign will take it in front too. So if you had I square root 3, this works on WebAssign, works for a test or quiz. But either way, if you like to write it behind, that's fine too. Whatever you like. This is the same thing. So let's look at example 5. We're going to write each complex number in standard form and simplify. So here we're multiplying our radicals. So if we're multiplying, we can combine it together under one radical. This would be the square root of negative 3 times negative 12. What's negative 3 times negative 12? 36. And then we can break it down from here. So it's a positive number. We don't even have to worry about i's. What's the square root of 36? Since the square root's already there, we don't put plus or minus. It's just 6. The only time we would put plus or minus is if we're evaluating and we take the square root of both sides. Any questions here? So if I had, let's say, square root 2 plus square root 3, can I add these together? No. They're not like terms. You'd have to leave them. If I had I square root 2 plus square root 2, can I add these together? No. You can't combine them together. They're not like terms, so you just have to leave it. We would want to put this in standard form, though, so make it square root 2 plus I square root 2. The imaginary part always comes last. Kylie?
Wait, why couldn't you add this together?
Because one's imaginary and the other one's not. So it'd be like if you had 2 plus 2I, you couldn't add them together. You just have to leave it separate. If I had, let's say, 4I square root 2 plus 3I square root 2, can I add these together? Yeah, these are like terms. So we just add our coefficients. We get 7I square root 2. The square root and imaginary part stays the same. All right, lastly, let's do C. So for C, I would like to just simplify the square root inside the parentheses if we can before we start, just to make it easier. So I'm going to take the negative out and turn it into an I. So I've got negative 1 plus I square root 3 squared. So I'm going to write it twice and FOIL it out. So negative 1 times negative 1 would be 1 minus I square root 3 minus I square root 3 plus I square root 3 squared, or yeah, I'll write it that way, I square root 3 squared. So we've got 1 minus 2i square root 3. Now for I square root 3 squared, we got to square the I and square the square root 3. What's I squared? I'll just leave as I squared for now. What's square root 3 squared? 3. So this would be times 3. And what does I squared change to? -1, so it'd make it a -3. Last step, got to combine my like terms. So 1 minus 3 would be -2. So -2 minus 2i square root 3. Is this in standard form? Yeah, real part has to come first, imaginary part comes second. All right, yesterday we did for A. I wasn't really thinking when I went through this, but we multiplied them together and got positive 36. Before we can multiply them together, you want to take out the negatives and turn it into i's. Then we can multiply them together, but outside that gives us I squared. And what does I squared turn into? -1. So that makes it -6 for our answer. So this would be -6. The reason is if I had something, let's say like square root -3 times square root -3, what would this be? If we had square root -3 squared, what would it be? -3. So we can't just multiply the insides together, make it +9, because then that would end up being 3. So you can kind of think about it as like square roots are like 2 halves of a whole. You can't just make it positive. The negatives are important here. So you would have to take the i's out first before you multiply the insides together. All right, example 6, we're going to solve each quadratic equation. How would we solve A? What would we do first? Subtract the 4. We want to get the x squared all by itself. And then we can square root both sides. So x equals what? Just 2i? Plus or minus 2i. So here we put the square root into our equation, so we need the plus or minus. When we're simplifying and we already have the square root there, if I've asked you to find the square root of 9, this would just be 3. But if I said something like A, where you have to solve and you're putting the square root into the equation, you need the plus or minus. Does that make sense? So if the square root's already there, you don't put plus or minus. If you're putting the square root and taking the square root of both sides of the equation, you need plus or minus. Let's do B. First, let's see if we can factor. I'm going to multiply the first times the last. We got 15. Do we have two factors of 15 that add to -2? 3 and -5. What's 3 times -5? -15. Was I looking to see what multiplies to -15? No. So does 3 and -5 work? No. Does anything work? No. So what do we have to do? If it doesn't factor, how do we solve? Quadratic formula. So our quadratic formula is -b plus or minus the square root of b squared minus 4ac over 2a. Yes?
Wait, why did -5
Because what's -5 times 3? -15. And we were looking for what multiplies to +15. So just got to be careful with the signs. So this is my A. 3 would be my A. -2 is my B. And 5 is C. So I get -2, which turns out to +2, plus or minus the square root of B squared. So that would be -2 squared. Minus 4 times 3 times 5 over 2a, so 2 times 3. So I'm going to simplify under my square root first. I get 4, I'll do it down here, 4 minus 4 times 3 times 5. 4 times 3 would be 12, and 12 times 5 is 60. And 4 minus 60 would be negative 56. So 2 plus or minus the square root of negative 56 over 6. Always, always, always simplify your radical if you can. I'll do it over here. Well, the negative comes out and we can turn it into an I. What are 2 factors of 56? 7 and 8. 2 factors of 8. 4 and 2. And 2 factors of 4. 2 and 2. So I have a pair of 2's. So 2 can come outside. So we've got a 2i on the outside. What has to stay on the inside? 7 and 2. So 14. So this simplifies into 2 plus or minus 2i square root 14 over 6. Can we simplify? You can only simplify if all 3 of your whole numbers are divisible by the same thing. You are not dividing into the square root. You just look at all 3 whole numbers. So all 3 whole numbers are divisible by 2. So we can divide them all by 2. We get 1 plus or minus 1i, which would just be I, square root 14 over 3. WebAssign probably doesn't want this as an answer. It will want you to break it apart. So we've got 1/3 plus or minus I square root 14 over 3. Which, again, WebAssign doesn't have that plus or minus. So you'd still have to split it up into 2 answers. So 1/3 plus I square root 14 over 3. 1/3 minus I square root 14 over 3. But this would be fine on a test or quiz. You can leave it all as 1. Oh, all right, really quick. I to the power of 1 would be I. I to the power of 2 is what? Negative 1. What's I to the 3rd power? Negative I. I'll tell you a shortcut when we come back, or tomorrow, but we're going to be asked to find something like I to the power of 105. And I'll tell you a shortcut. All right. So before we start, just to get an idea, if I had I to the power of 0, what would this be? 1. Awesome. Anything to the power of 0 is 1. What if I had I to the 1st power? What would that be? I. I to the 2nd power would be negative 1. And what about I to the 3rd power? Negative I. Awesome. So we're going to kind of keep this in mind and do I to higher degrees. So what if I had I to the 10th power? What would this be? And how do we know? Not just because it's even. You're right, but it's not just because it's even. Because what if I had I to the 8th power? Would this also be negative 1? But how do we know? You could do that. But what if I had I to the power of 106? Be a little bit harder to write it out, right? A shortcut that you can do to find these is you can divide by 4. So divide the exponent by 4. And whatever your remainder is, you're going to use these rules here. So 10 divided by 4 would be 2 with how many left over? 2 left over. So it'd be like an I squared. And what's I squared? Negative 1. What's 8 divided by 4? How many do we have left over? If it'd be 2 with the remainder of 0. So what's I to the 8th power? 1. What's 106 divided by 4? How many is our remainder? 2 would be our remainder. So what's I to the power of 106? -1. It'd be the same as I squared. So whatever your remainder is, you're going to follow these rules here.